Hello my dear friends and students, this is Sir Palmath and welcome to my video channel. In this video, this is the part 1 of your lesson which we are talking about the multiplication of radical expressions. Let us start with our learning objectives for today's lesson. My dear friends and students, so this is our objectives for today's lesson. Let us begin with our first objective. So we are going to apply simple product rule to determine the products of two or more radicals. And second, you will be going to simplify algebraic expression that containing of radicals using the multiplication properties. Okay, so let's move on to our lesson proper for today's lesson. So today we are talking about the product of rules, so which involves to the multiplication of radical expressions. So for product of the roots, it states in the given definition, if the value of A and B are real numbers and A is greater than or equal to 0 and B is also greater than or equal to 0, then it is defined by the given formula for the product of the roots, which is nth root of A multiplied by the nth root of B is equal to the nth root of the product of the roots A and B, or n root of A and B. So my dear friends and students, in general, the product of the principal n root of two or more real numbers is the nth root of the product of these numbers. So this is the simple product rule that uses the multiplication of any radical expressions. So by that, so let us discuss about the multiplication of radical expressions. This is the part 1 which we are applying the simple product rules together with the distributive property rule. So my dear students, so how will we going to multiply radical expressions? So to explain with that the step-by-step process, hereby with our illustrative examples. So let us begin with our first illustrative example, number 1. So you will be going to multiply and simplify the following radicals. Letter A, we have the square root of 7 times the square root of 5. For letter B, we have 12 times the square root of 3A times 4 square root of 4b. For letter C, we have 8 square root of 10m times 5 square root of 2m. And for letter D, we have 3 or the cube root of 18xy squared multiplied by the cube root of 6x to the power of 6 y to the power of 4. So my dear students and friends, to simplify among of this product of two radicals, here is our solution. So to solve this any set of problems, let us start with letter A. So then we'll be going to simplify the two roots. We have the square root of 7 and the square root of 5. So my dear friends and students, so the first step to do is to state with the given. And of course, simple as that, we will be going to apply the product rules. So square root of 7 times the square root of 5, it becomes the square root of the product of 7 and 5. So we have the next step to do is to simplify 7 times 5, so we get a product which is the square root of 35. So that is very simple. Let's move on to the next example for letter B. So you will be going to simplify 12 square root of 3a times 4 square root of 4b. So we have already stated given, so all the red marks, we have the 12 and 4 should be multiplied these two constants. So we are applying the product rule, so distributive process, we have 12 times 4, and of course the black ones we get 3a times 4b. The next process to do is to multiply all together. So we have 12 times 4, it becomes 48, 3 times 4, the numerical coefficient which is 12, and of course a times b, we have ab. So that is 48 square root of 12ab. The next step to do is to factor out at least one of the factor which is a perfect square. So we all know that we factor out 12ab. So 12, we get 4 times 3 and copy among these two variables ab. So it becomes 48 square root of 4 times 3ab. The next step to do is to extracting the roots. So we have at least one perfect square number inside the radicand, which is 4. So we get the square root of 4, which is equal to 2. And then we will be going to simplify the product of these two constants. So 48 times 2, it becomes 96. So we have 96 times the square root of 3b. And that is our answer. So let's move on to the next illustrative example. We have for letter C, how we'll be going to simplify 8 square root of 10m multiplied by 5 square root of 2m. So we have the given, of course. The next step to do is to apply this product rule using multiplication. So the coefficient of the every radical term, 8 and 5, so we express as the product. So 8 times 5 times the square root of inside the radicand, so we have 10m times 2m. After that, you will be going to simplify the given product simultaneously. So 8 times 5, it becomes 40. And of course, 10 times 2, the numerical coefficient, which is 20. And m times m, which is m squared. So by applying the exponent law, so 1 plus 1, it becomes 2. So the next step to do is to factor out perfect squares. At least we have we factor out first 20m squared. So that is 20 times 5. So at least we have a perfect square, which is 4. And of course, we factor out m squared. Then 4m squared on the first factor, while 5 on the second factor. So that is 40 times the square root of 4m squared times 5. After that, you will be going to extracting the roots. So since 4m squared is a perfect square, so we get the square root of this. So it becomes 4, the square root of 4 is 2, the square root of m squared, simply m. So we have 40 times 2m multiplied by square root of 5. And of course, we get the product of this. We have 40 times 2 becomes 80, copy the variable m, so 80m multiplied by the square root of 5. And that is our final answer. So let's move on to the last example in this illustrative example, so which is letter D. So how will you simplify the cube root of 18xy squared times the cube root of 6x to the 6th power y to the 4th power? So the first step to do is to state the given first, and then you will be applying the product rule, so same as it is. So we have the cube root of the first root, which is 18xy squared, multiplied by the second root, which is 6x to the 6th power y to the 4th power. So that is applying the product rule. The next step to do is to simplify the product. So we have 18 times 6, so we get 108. We have the literal numerical coefficient. So x times x to the 6th power, it becomes x to the 7th power. So x exponent is 1, and other is exponent of 6. So add together, we have 7 power. Next, we have the base y. So y squared multiplied by y to the 4th power. So by applying the exponent rule, which has y to the power of 6. So that is the cube root of 108 x to the 7th power y to the 6th power. The next step to do is to factor out the perfect cubes. Since the given radical term is a cube root, so we find the possible factors at least one perfect cube. And that is the possible factors of 108, which is 27 times 4. So we all know that. We eliminated the perfect cube number, so that is 27. And we have to factor out x to the 7th power, which has at least a perfect cube number with an exponent. So the exponent should be considered, it has a multiples of 3. The exponent like 3, 6, 9, 12, 15, 18, and all multiples of 3. So we factor out, it becomes x to the 6th power. So it has a perfect cube. And remaining x is one exponent. And copy y to the 6th power since the given expression is a perfect cube. So it has a multiple of 3. So it becomes cube root of 27 x to the 6 y to the 6 times 4x. The next step to do is to extracting cube root. So we simplify 27 x to the 6 y to the 6. So the cube root of 27 is 3. The cube root of x to the 6 is x squared, so yx squared, because now we divide the exponent of 6 to the nth root. So 6 divided by 3, it becomes 2. Same with y to the 6th power. So 6 to the cube divided by 3, it becomes y squared times the cube root of 4x. So 3x squared, y squared times the cube root of 4x. And that is our final answer. So, you know, my dear friends and students, on how will you going to multiply these two radical expressions. So let's move on to our next illustrative example number 2. So write as a single radical expression given the product of these two radicals. So we have letter A, we have the square root of 3 multiplied by the cube root of 5. And for letter B, we have the square root of 2x multiplied by 4 root of 2x squared. So in this set of problems, in every radicals has a different indices. So for example, we have letter A, the square root multiplied by the cube root, and for letter B, the square root multiplied by the 4th root. So to solve this, in order to us to simplify the radical expression as a product into single radical expression, so here is the solution to the given problem. Okay, so to write as a single radical expression given the square root of 3 times the cube root of 5, so we have the given. Of course, in order to us to express into single radical expression, so let us write each of the radicals into exponential form. So we all know that the symbol is square root, so it has a denominator of 2, and we have the inside the radicand, which is 3 raised to the power of 1. So we convert into exponential form, it becomes 3 raised to the power of 1/2. Okay, the next is the second radicand, since cube root of 5. So we all know that the cube root, it has a denominator of 3 in the given exponent. So it has 3. And 5 is on the numerator, exponent of 1. So it becomes 5 raised to the power of 1/3. So we have 3 raised to the power 1/2 multiplied by 5 raised to the power of 1/3. After that, we'll be going to change the exponent similar fraction by the least common denominator of 2 and 3, which is 6. So in these exponents, you convert 1/2 and 1/3 to make similar fractions. We have the same denominator. So we all know that the LCD of 2 and 3 is 6 because 6 can be divided both between 2 and 3. So there are similar fractions, which is an denominator of 6. Then we will be going to convert into equivalent fractions. So 6 divided by 2, it becomes 3 multiplied by 1, so we put 3. So 3/6 is equivalent to 1/2. And 6 divided by 3 is 2 multiplied by 1, so we get 2. So 2/6 is also equivalent to 1/3. And after that, you will be going back to radical form. So 3 to the power of 3/6, it becomes the 6th root. So 6 is the denominator, copy the base, and of course 3 is on the numerator, so that is the 6th root of 3 cubed. Multiplied by, convert it, 5 raised to the power of 2/6 into radical form. So since 5, you have to copy the base. The 2 is part on the numerator, which is 5 squared, and 6 is on the principal root, which is on the 6th root. So that is 6 root of 5 raised to the power of 2. So 6 root of 3 cubed multiplied by the 6th root of 5 squared. And that, you will be going to simplify the exponential values of 3 cubed and 5 squared. So 3 cubed, which is 3 times 3 times 3, so we get 27. And for 5 squared becomes 5 times 5, we have 25. And then apply the product rule. So 6 root of 27 multiplied by the 6 root of 25, so the indices are similar, so we can use the product rule. So 6 root of 27 times 25, so we get the 6 root of 675. So since 675 is not a perfect sixth root and it is prime to all the perfect roots, so that is our final answer, which is the sixth root of 675. So let's move on to the next example for letter B. So in the same manner, you will be going to simplify as single radical expression to get the product of this. We have the square root of 2x and the fourth root of 2x squared. So in this situation, we have the different indices. So we have the square root and we have the fourth root. So to get this product as a single radical expression, so we have the given, and then you will be going to convert into exponential form, from radical form to exponents. So we have the base is 2x. So don't forget to put a parenthesis if the inside radicand is an monomial. So 2x as a base. Then since 2x, you have to raise the power of 1. So the numerator of the exponent is 1. And we have the square root order, which has an exponent of 2. So we have 2x raised to the power of 1/2. Multiplied by the fourth root of 2x squared. So convert it since 2x squared. So copy the monomial 2x squared inside the radicand. And then we put the parentheses. And of course, we have to express this becomes 2/4. Okay? So write in exponential form. And after that, we will be going to make a similar fractions. Okay? So we also that 2x squared has an exponent of 1, so it becomes 1. Okay? So make the exponent similar fraction by the least common denominator of 2 and 4 is 4. So express these exponents into similar fractions and to make it equivalent fractions as well. So we all know that the LCD of 2 and 4 is 4 because 4 can be divided into 2 and 4. So we have 4, we have the same denominators of the every exponents. Next is we have the fourth root of, okay, we have the 4 divided by 2, which is equal to 2 times 1, we have 2. 4 divided by 4 is 1, multiplied by 1, it's also the same, we have 1/4. Okay, the next step to do is to express going back to radical form. So which is the fourth root of 2x raised to the power of 2 multiplied by the fourth root of 2x squared. So simplify the exponential values. So it becomes the fourth root of 4x squared times the fourth root of 2x squared. So we have the same indices. So by that, we get the product. So 4x squared multiplied by 4x squared. So we have the fourth root of 8x to the power of 4. So extracting the perfect fourth root. We all know that we eliminated x to the fourth power. So we eliminate x to the fourth power, it becomes x only. And copy the fourth root and remaining factor inside the radicand is 8. So the final answer is x to the fourth root of 8. And that is our final answer. So my dear friends and students, so let's move on to our next illustrative example, number 3. For number 3, you'll be going to multiply the following radicals using the distributive property, then simplify the following. We have letter A, we have the square root of 3 times the quantity of the two terms, square root of 5 plus 2 times the square root of 6. And for letter B, we have 4 square root of 3 times the quantity of the two terms, 5 square root of 6 minus 2 square root of 2. So, to simplify this radical expression, here is the solution. But, let us define first the distributive property of multiplication. So, we let A, B, C are real numbers. So, real numbers are just any characteristic or any kind of numbers. It might be an integer, it might be a negative number, a decimal, a fraction, rational or irrational numbers. So, we have in distributive property of multiplication in the form of A multiplied by the quantity of the binomial B plus C, which is equal to A times B plus A times C. So we distribute the product of A and B and of course A and C. That is the distributive property of multiplication. To multiply our radical expressions in the form of the square root of A times the quantity of the binomial square root of B plus C square root of D. We are going to use the distributive property of multiplication all over addition. So we have already presented an earlier, and that is the product. We have the square root of A times the quantity of the binomial square root of B plus C square root of D, which is equal to the product of these two roots, the square root of AB plus C times the square root of AD. So where A, B, and D are just positive real numbers. So we all know that this is the process on multiplying radicals using the distributive property of multiplication. Let's go back to the given radical expression for letter A. So to simplify, the square root of 3 multiplied by the quantity of the square root of 5 plus 2 square root of 6. So the first step to do is we have to use the square root of 3 in order to us to multiply using the distributive property rule. So by this, we have square root of 3 times the square root of 5 plus the square root of 3 multiplied by the 2 times the square root of 6. So we use the distributive property rule. After that, we use the simplify each term, which is using the product of roots. So we have the square root of 3 times square root of 5. So we apply the product rule, it becomes the square root of 15. Then plus square root of 3 times square root of 6. So it becomes 18, and copy the coefficient of the radical term, which is 2. So we have 2 square root of 18. So square root of 15 plus 2 times the square root of 18. The next step to do is to factor out 2 square root of 18. So on the second term, we are going to factor out inside the radicand, which is 18. So the possible factors of 18 are 9 and 2. So at least we have the perfect square, which is 9, in order to us to eliminate the given perfect square. So extracting the root, so 9 square, we have to get the square root of the value, which is 3. So we have square root of 15 plus 2 square root of 3 times the square root of 2. And that, so to simplify the product, 2 times 3, so we have 6. So it becomes square root of 15 plus 6 square root of 2. And that is our final answer. How about for letter B? So you'll be going to simplify 4 times the square root of 3 multiplied by the quantity of the two terms 5 square root of 6 minus 2 square root of 2. So to simplify the given radical expression using multiplication, so we apply the distributive property. So we use 4 square root of 3 as a number should be multiplied using distributive property. So we have 4 times, the square root of 3 times 5 times the square root of 6. And we have copied the sign. So minus 4 square root of 3 times 2 times square root of 2. So we have the product of these two on the second term. Next is simplify each product or each term, the product of the roots, all of these terms simultaneously. So let us start with the number. So 4 times 5, it becomes 20. 3 times 6, which is 18. So 20 square root of 18. So minus 4 times 2, it becomes 8. Square root of 3 times square root of 2, which is square root of 6. So that is 20 square root of 18 minus 8 square root of 6. Next step to do is to factor out 20 times square root of 18 on the first term. So we factor out inside the radicand, which is square root of 18. So the possible factors of 18 are 9 and 2. At least we have a perfect square, which is 9. And after that, you will be going to extracting the roots. So since we get the square root of 9, which is 3. And copy the last term. And then we get the product of this 20 times 3. So we get 60 square root of 2 minus 8 square root of 6. And that is our final answer. So my dear friends and students, so that's These are the following illustrative examples on how will you going to multiply these two radical expressions using the simple product rule and distributive property of multiplication all over the terms. So that's the end of our video. So thank you for watching. So please like, share, and subscribe, and hit the notification bell at Sir Palmath TV in this YouTube channel. So thank you for watching, and God bless us all.